On September 12, 2025, astronomers detected something that shattered every expectation they had about how the universe behaves. A colossal object blazing in from the darkness of deep space, with a tail stretching across the sky 5 times the width of a full moon, so enormous that even amateur astronomers with backyard telescopes could see it. Within hours it was confirmed this was no ordinary comet. It was something far larger, far brighter and far stranger than anything we have ever recorded. Officially catalogued as C21025R2, now simply called SWAN. But the timing is what truly froze scientists in disbelief, because another object, the already infamous 3MI Atlas, was also inbound, racing toward the sun from the exact opposite direction of the sky. Both set to reach their closest approach to the sun within the same 10-day window, both hidden by the solar glare during their most critical moment, and both displaying anomalies that defy the laws of nature. The odds of such a cosmic double entry happening by chance are so vanishingly small that some scientists have stopped calling this coincidence and started whispering the word mission. If one interstellar object was strange enough, then the arrival of a second one, 100 times larger, targeting the same solar corridor suggests we may not be witnessing accidents of astronomy at all. We may be watching an operation. As data poured in, what first stood out about SWAN wasn't just its size, but its behavior. Unlike typical comets, which scatter light in predictable patterns, SWAN's reflective properties showed metallic signatures, hints of nickel and cobalt, the same materials we humans use to forge durable alloys and protect against corrosion. Some researchers began calling it the Fortress because while most comets break apart under the stress of the sun, this one seemed shielded, armored, even maintaining a brightness curve far beyond what natural ice and dust could explain. And its tail, already record-breaking in length, did not behave like chaotic vapor, but pulsed with subtle rhythmic changes, as if controlled micro-thrusts were guiding its motion. Imagine watching a skyscraper-sized tank drift through space, cloaked in a shimmering halo that might not just be gas, but an electromagnetic shield deflecting the fury of solar winds. That is the image scientists are now grappling with. But even more unsettling than its scale is its timing. Because while SWAN looms as a fortress, its smaller counterpart, 3MI Atlas, behaves like a drone, agile, erratic, with strange bursts of acceleration and tail color shifts that no natural process can fully explain. Together, they don't look like random visitors. They look like pieces of the same puzzle, 2 parts of a system converging on the sun at the same time, hidden from us during the very days when their true purpose might be revealed. When astronomers plot the arrival vectors of SWAN and Atlas on a star map, something extraordinary emerges. SWAN comes from Aquarius, Atlas from Sagittarius, 2 origins separated by more than a quarter of the entire celestial sphere. Yet despite their radically different approach angles, they both cross into the inner solar system at nearly the same solar distance, reaching perihelion within just 3 days of each other. Statistically, this kind of synchrony is impossible. Random comets scatter their arrivals across decades, sometimes centuries, but never like this. And then comes the blackout. From October 8th to October 18th, the sun's glare blinds our telescopes, creating a window where neither SWAN nor Atlas can be directly observed. The result, their closest approach to the sun and to each other, happens at the exact moment when Earth's instruments are unable to see. To many, this looks less like coincidence and more like coordination, as if their paths were deliberately engineered to meet under the cover of solar interference. Think about that. 2 anomalies arriving together, timing their rendezvous to the one place and time we cannot watch. In orbital dynamics, astronomers call this a corridor, a narrow window of space and time where 2 objects align in a way that defies randomness. And this corridor, whether by chance or by design, has forced the scientific community to confront a possibility it has long avoided. What if they are not just passing through, but converging for a purpose? While orbital mechanics raise questions, the energy data raises alarms. Atlas has already shocked researchers with bursts of acceleration that mimic thruster-like maneuvers, each pulse requiring the output of 10 nuclear power plants to explain. But SWAN makes even that look trivial, because its implied energy levels are on the order of 10,000 gigawatts, more than the entire power grid of Earth. No natural comet nucleus can produce such raw output. Its reflective metals, its persistent halo, and its rhythmic pulses suggest not outgassing, but control. Like a machine using plasma bursts to steer itself. The idea of engineered propulsion, once dismissed as science fiction, is now quietly circulating among astronomers who can no longer ignore the numbers. And then there's the timing of the pulses themselves, regular enough to resemble a signal, patterned enough to hint at communication, and so consistent that some are calling Swan not a fortress, but a beacon. If Atlas is a drone maneuvering and adjusting, then Swan might be the mothership, a colossal structure designed to survive millennia in space, arriving now not by chance but by cycle. With an orbital period of more than 22,000 years, Swan could have passed this way long before recorded history, maybe even during the last ice age, leaving traces that our ancestors might have remembered as myths, carvings, or warnings. And now it is back, aligned once more with another anomaly, as if to remind us that we are not the only intelligence shaping the sky. Just when the world's curiosity reached its peak, silence descended. NASA, ESA, and other agencies quietly restricted data releases, suspending high-resolution imaging and radar tracking during the very days when the two objects would be closest to the Sun. Officially, this was explained as solar conjunction downtime, a standard safety measure. But behind the scenes, leaks revealed that orders were explicit. Avoid public statements, deny requests for raw data, and reroute proposals for alternative observations. The blackout wasn't just natural. It was enforced, and yet the silence of institutions only amplified the voices of independent astronomers who rallied across forums and private networks to keep their telescopes pointed at the sky. Groups like the Abaro Tracker Collective in Spain and Bill Gates' distributed telescope network began sharing data, desperate to capture even fragments of information that governments refuse to release. This grassroots resistance has fueled speculation that something extraordinary is happening behind the curtain, something agencies do not want the public to see. Because if Swan and Atlas are converging for a purpose, then the real question isn't just what they are, but why they're here now. And if their meeting was engineered, then humanity has already stumbled into the middle of a mission we were never meant to witness. As telescopes tracked 3I Atlas, something unusual emerged. Its tail wasn't just glowing. It was changing in a way that seemed deliberate. Over a span of weeks, 3 sudden accelerations were recorded. Each one sharp and unexpected, spaced almost like clockwork, and each coinciding with a strange color shift in the tail. One moment the glow would tilt red. The next it would shift to neutral, then snap back again, as if an unseen mechanism was adjusting its propulsion. Natural outgassing from comets happens gradually, driven by the sun's heat. But what Atlas displayed was abrupt, rhythmic, and controlled. Energy estimates suggested the power required for each thrust was equivalent to 10 nuclear plants working at full capacity. For a chunk of ice and dust, that should have been impossible. For a machine, it would make sense. Meanwhile, Swan's massive structure mirrored this behavior at an even larger scale. Its gigantic tail wasn't chaotic, but pulsed with microbursts that nudged it subtly, like course corrections made with precision. Both objects, one small and agile, the other vast and unstoppable, seemed to be maneuvering within the solar system not as wanderers, but as participants in a plan. And the chilling part was this: their thrusts weren't random. They appeared synchronized. Orbital dynamics are the one thing astronomers trust to reveal truth. But here the truth is unsettling. Swan and Atlas, though arriving from completely different directions in the galaxy, lined up to occupy the same narrow corridor of space and time. Their perihelion points, those closest brushes with the Sun, ended up only 50 million kilometers apart, a distance smaller than the gap between Earth and Mars, their timings within 3 days, and all of this unfolding during the exact solar blackout window when Earth-based telescopes were blinded by glare.